Hey guys, this is Carson from AUBIE1. So today I'll be showing off a simulator I've been writing, very basic physics simulator for the V5 brain. So essentially what I did is I took the V5 header and I wrote a very basic physics implementation for it. That way I can just drag and drop my robot files directly into VS Code and then have it simulate the field. So I'd be able to build my motor control libraries and navigation libraries without having physical access to the bot. So what you do is you can just configure driver tank setup with the location of your tracking wheels relative to your base, orientation, wheel radius, etc. with an inertial sensor or not to tell you where you're going. You can go ahead and configure the simulator up. And then this is a navigation class I wrote that we will be looking at to see how reliable it is. We go ahead and start it near the center of the field, and it'll let us know where it is in the simulation. And by the end of it, we'll see where it is in the simulation, see how my navigation library held up, and what the encoders for each side look like. So the motor navigation library only updates every 10 milliseconds, while the simulator updates 10 times per millisecond. So we'll get to see how that interacts. You interact with the system just like how you interact with your robot. You just set the motor velocities in terms of percentages. So what I did is I went ahead and set off the right motor at 100 and the left motor at 58. So it should start off by turning left. And then I have the right motor slow down and left motor speed up so we can actually see how it handles turns and all that. I just had it go ahead and change 30% every 3 seconds. And then we can even simulate it onto a graph and see how that plays. So I'll go ahead and show it off here. So as you see, it went off to light, and then as the left side speeds up and the right side slows down, it'll get more and more involved until it's just turning in circles. And then we can see the starting point, the simulated endpoint, and the navigation point after about 10 seconds or so. I think I have it set on 30 right now. But it held up pretty well. Of course, this is assuming no slippage or anything like that. But we're just building a basic simulation since we don't have robot access. The simulation played 100%, 107% faster than real time. So that's what I got right now. Just drag and drop replacement. I can link the GitHub in the description in case y'all want to mess around with it. But yeah, till next time.